Chair, sir, Vice Chancellor, sir, distinguished delegates, good afternoon. With this preamble, I'll introduce you to my presentation topic, preliminary analysis and management of specular radar cross-section in Sri Lanka Navy inshore patrol craft. Introduction. This research work analyzes specular radar cross-section considering structural characteristics of Wave Rider class inshore patrol craft. What is RCS? RCS is basically what we get back as a reflection from a target onto our radar receiver. RCS management is basically manipulating the RCS to gain the competitive advantage in view of optimal operational effectiveness. So it is paramount important for the survivability of a craft. The high signature levels provide information to the unwanted parties for detection, classification, identification and tracking, and also finally the homing guidance. Talking about the IPC is an indigenously designed craft meant for operational concepts of swarming and saturated deployment. So let's go into the salient points of this craft. It is basically made of GRP, and let me move on to the motivation of my presentation. No studies have been carried so far on this subject, hence a research vacuum is existed in this area. IPCs are basically extensively utilized for inshore patrolling tasks near to the coastal line. Here I selected this craft for my research because it is easy improvability due to indigenous technological base. Let me quote an interview with Jane's Defence Weekly by present Commander of the Sri Lanka Navy. Main focal points are effective and efficient coastal surveillance, keep the sea area free of piracy and armed robbery, intelligence operations. So with this background, it is well understood that the requirement of having a least R radar cross-section for the naval craft, especially naval patrol craft. Research objective. The research objective is to analyze and propose hull and superstructural amendments for Sri Lanka Navy IPCs. Let me just rush through the scattering mechanisms. When a craft is illuminated by radar, there can be multiples of mechanisms as given in this slide, single, double and triple, as well as the diffraction from the edges. So how to reduce the radar cross-section? There are passive and active cancellation techniques as well as radar absorbing materials used heavily by other navies. During this research, I used the last method of shaping. Shaping is basically orientation of target surfaces and edges to reflect back the minimum amount of energy towards the radar receiver. So why I selected shaping is because the dominant multiple bouncing and scattering effects present in ships is very special for marine environment, and the shaping method is very economical and least maintainability requirements with respect to other methods, as well as the weighting factor is there. For example, the radar absorbing materials, it added the weight up from 1 to 8 pounds per square feet. So the weight of the ship increases, and as well as the water intrusion problems with the radar absorbing materials. Methodology. Here we generated number of 3D simulation models on the IPCs, and extensive simulations of radar cross sections were analyzed for S and X radar bands. These are the simulation parameters we followed. So with that background, may I move on to the results of our research. This is the basic, the original model of the IPC, and you can see the radar cross section. This is in S band, we have 156 peak value, as well as in X band we have 166 peak value. So with number of models, like model A, we are reducing here up to 22, and we kept on experimenting with number of models, and finally it came to a turning point in our experiment. Here you can see we are almost reducing the frontal part of the frontal part is reduced to a minimum. So the reflection is minimum at the frontal part. Same in the X band, and again more improvements in the model F. There are least number of reflections from the frontal side of the craft. Same in the X band, and here in the model G we have achieved almost total cancellation of the reflections from the stern or back side of the craft. You can see very minimal reflections from the back side of the craft. Same in the X band. Here in the model H, we managed to cancel both sides from both frontal as well as the back side of the craft. You can see only either side we are getting the reflections. So 180, 270 and 90. So both sides from the front as well as from the back we are getting minimum reflections. So virtually if you are looking from the front you cannot see the craft through the radar. Again same in the X band. And here this model L, we have managed to get total cancellation of reflection from either side, that is these sides. Same in the X band. Conclusions. Surface normals should not point in high priority threat directions, and specular component is frequency independent, and purely vertical and horizontal superstructures are unfavorable for low radar cross section, and the maximum intensity of the distracted lobe increases with the H length. Now here the summarization of the results, you can see the model G is has the lowest maximums, as well as the reduction. We can see the model G, H and L has got the maximum reductions. So before going to recommendations, I will show you some of the I will show you 4 models, that is E. So this is the craft. You can see we have done some tapering in the main hull, and some amendments to the superstructure also. Then F, again G, I will show you the G model. You can see we have introduced some 3D area, this area, as well as stern we have introduced these shapes, and also superstructure. And I'll just go through H. Here we can see the all newly designed superstructure. So with that, I'll move on to the recommendation. In consideration for the incorporation of aforesaid findings on the future craft designs and consideration of shifting to more superior formulas of GRP in view of achievement of superior characteristics and lower dielectric constant than conventional GRP, which as we use now, as well, such as this S2 glass fiber, which gives you 20% superior performance in radar cross section, as well as I request more research on radar absorbing materials with alternative and locally available low cost substances. Thank you very much.